A heavy turbine rotor of a sea vessel rotates at 1500 rpm clockwise from when looking from stern, its mass being 750 kg. The vessel pitches with an angular velocity of 1 radian per second. Determine the gyroscopic couple transmitted to the hull. Hull means body of the ship. Okay. Hull, when the bow is rising, the radius of gyration of the rotor is 250 mm. Also show in what direction the couple will act on the hull. Do you understand the entire question? So, there is a propeller of the ship. The simple photograph of a ship propeller is shown to you. Only the propeller is shown to you. It will be mounted at the bottom of the ship. Okay. Entire thing. It is shown upside down. Okay. The heavy turbine rotor of a sea vessel, the N is 1500. Okay. And the direction of rotation when you look from the stern is 750. Direction of rotation is clockwise when you look from the stern. Right? First case. Initial 4 tabulation. Initial 4 rows of the table. Okay. The mass is 750 kg. The pitching velocity omega p or omega 1 is 1 radian per second. Determine the gyroscopic couple transmitted and what will happen. The effect of the reactive couple, radius of gyration of rotor is 250 millimeter. Okay. So these data are listed below. 750 kg, radius of gyration 0.25. Rotor speed is 1500 spin speed. Okay. So that when I convert it to omega, it comes around 157.1 radians per second. And precisional velocity. When the rotor is rotating, I am pitching the ship. Okay. How the pitching is done? Transmitted to the hull when the bow rises. Front end of the ship is rising, back end is going down in a pitching motion. What will be the gyroscopic, reactive gyroscopic couple effect on the ship? Okay. So that pitching speed is 1 radian per second. About the mean axis. Okay. So we know that mass moment of inertia of the rotor mk square, I equal to mk square, 750.25, it comes around 46.875 kilogram meter square. Okay. So gyroscopic couple transmitted to the hull, I omega omega p. Omega p is also given to you in the question itself, 1 radians per second. Okay. So omega just now we have found out initially some 1500 radians per second. That omega you write here. So in a moment of inertia, mk square is 46.875 kilogram meter square. So this is your 1500 rpm of the rotor, 157.2 radians per second. This is your pitching speed. Omega precisional speed or pitching speed is 1 radians per second. So I'm finding out the value of gyroscopic couple comes around 7364 Newton meters. Therefore, the value of active couple is 7.364 kilonewton meter. So now what is the effect of this gyroscopic couple on the ship? Now when I look from the stern, my rotor is going around in clockwise direction. Now I am pitching the ship. The result will be rolling. So either to the left or the right, the ship will roll. That you have to say correctly. Okay. So we have discussed earlier that when the bow is rising, that is when pitching is upward, reactive gyroscopic couple acts in clockwise direction, which moves the sea vessel towards the starboard. So the table, if you go back and see, you will see that ship will roll to the right. When your bow is rising and your rotor, when looked from back, is going around in clockwise, and your front end of the ship is going up, your ship will roll to the right or starboard side. So that is the conclusion statement you have to give in this problem. So that completes the problem. This is taken from a Kumi textbook problem 14.4.